Okay, so now time for the Hackfest. Let me first find the pointer. So first of all, and to give a bit of context on this Hackfest, what I want to highlight is what will we work on during the next hours. As Ricard was stating, with Teraflow the idea is that we can manage networks, and here the Hackfest that we prepared is kind of a subset, a small portion of another demonstration that is to be shown tomorrow and the day after tomorrow on the other floor, involving open source Mano, open slice, and Teraflow SDN. Well, this is done in the scope of the Across project, and we think it will be nice that you can play a bit with some of the elements and the very same elements that we will be using tomorrow and the day after. So the focus for the demo, it will be explained tomorrow. I will not spoil you, but the point is that we will focus on the networking part, and in particular in the routing using the IP routers through an emulated ContainerLab environment, and everything managed by Teraflow using IETF data models. Okay. For the rest, tomorrow you will have additional details. Then, going ahead a bit on the work environment that we prepared. We prepared a virtual machine that contains all the software that you will need. It was circulated, the link for downloading this virtual machine, I will say I think it was on Friday, if I'm not wrong. I hope you had the chance to download this virtual machine. If not, what I recommend, instead of downloading it directly, is to pass by the front desk here, and Roger has 5 USB sticks with a copy of the virtual machine. That way we will not overload the Wi-Fi of Etsy downloading these huge files. I say because it's quite a number of gigs, so it's better if you can copy the files directly. Besides the virtual machine, what you will need in your laptop in order to follow properly the Hackfest will be just a web browser, VirtualBox 7, because it's the virtualization environment we use to create the virtual machine, and well, if it's not, and some form of SSH client. For that you can use Mova Xterm, for instance, maybe VS Code, the one that you feel more comfortable. So there is no constraint on that. In terms of networking, you will have to expose the ports 22 for SSH, 80 for HTTP, and this port, the 50,080 for the CLAB part. In principle, in the virtual machine, I think it should be done, but probably after I finish this brief introduction, we can discuss together also with Roger and see who is planning to participate in the Hackfest, and arrange a bit more the technical logistics. More things. In terms of material, well, you have the link, so you can. This is one of the links. In the wiki page, you have the other. You have a couple of links to download this file for the virtual machine. All the commands that we are using during the Hackfest are collected in a README file. Okay, so if you are participating, you don't need to tape all the commands by hand because it's quite error prone. And also we provide this file because that way we avoid the issues that happen usually when you copy from a PDF file, a PowerPoint file, that sometimes some specific characters are altered, and well, this usually raises some issues. So it's better to copy the commands directly from there. If it's more comfortable for you, you can open directly in the GitLab repository the file, so that way you can have all the files in a single tab. After starting the virtual machine and having it running, one comment. We were updating the branches that we use in the Terraflow repository, so we recommend you to go to the TFS CTRL folder. Ensure that you are in the right branch. It should be, but it's not bad to test. So you need to git check out to the feature Hackfest 5, and then do a git pull in order to download the latest updates in the code, because there are few code fixes that will probably avoid trouble. Before starting with the part of the protocols, just before starting this session of the Hackfest, I was trying to redeploy Terraflow, and given that this is a Hackfest and things need to be funny, somebody has updated some dependency in some of the components of Terraflow, and what happened, instead of 2 minutes for deploying Terraflow, that is what happens when you already build it, it's taking like 20 minutes. My recommendation, let's invest now few minutes in order to prepare logistics, technical logistics, ensure that all the participants can get access to a virtual machine for playing, and then we will jump directly to the section on deploying Terraflow, because then while Terraflow is deploying, during these 20 minutes, I can jump to the other part more related to the introductory part, protocols, and so on. I don't know if clear up to here. For sure, if at any point you have any question, doubt something is not working, whatever issue, you can interrupt us, and we will try to help you as best as possible. Then maybe Roger, we can make a round and a question and see who is participating in the Hackfest, in the hands-on, let's say. Who has the intention to participate? Let's count. 1. Okay. Other question. Who has the virtual machine installed? Okay. No, some people. Then who needs the virtual machine or needs a NetCBeam virtual machine? Because we prepared 5 virtual machines at the NetCBeam. In case your laptop, for instance, is not powerful enough to run the virtual machine or something, we have 5 of them. So if some of you need, okay, I see 1, 2, 3, 4, 5. That's perfect, because I think it's exactly the number of virtual machines. 3 more, okay. We have 3 additional ones. So probably you can give the... Okay, so probably you can give them the credentials, IP addresses, and so on to join or to connect to the virtual machine. Yeah? No, but just below the form for authentication, there should be a link saying just download the file, in theory. In the window where it asks for authentication for the Dropbox, there is another link where you can click and just download the file. Ah, really? No, but I think it should be public. Let me. In principle, I'm not logged in, and I'm able to open the file. Maybe the problem is another. Okay, good. Then, who needs the USB sticks in order to get the virtual machine? Eh? No. I'm asking for those that need the USB stick to raise the hand. I'll be jumping here to the PowerPoint. For others having the virtual machine, what we can do is start the virtual machine. Some comments in terms of settings for the virtual machine. Later I can repeat if you missed that point, no problem. In the network section of the virtual machine, I recommend you to double check that you have the proper port forwarding. You will need, as I said, 3 ports. So one is for the ContainerLab, the other is for the HTTP that we use for the web user interface of TerraFlow, and the third one will be for the SSH, okay, for connecting to the terminal of the virtual machine. You can just copy these settings if you want. They should work. This will expose these 3 ports in the virtual machine to the same 3 ports in your host. Okay, so that way you will be able to log in to the virtual machine directly. Okay. So is there somebody that needs support in order to prepare the virtual machine and get connected? Is everybody set up? Sorry?
The forwarding rules were part of which button press?
Yeah, let me, when you click the virtual machine in the settings, you have this network block, and in advanced,
oh, okay, it's in advanced, okay.
You have the port forwarding, and okay, there you can configure the forwarding rules.
Yeah, because there's no CLAB-G in the VM that downloaded.
Yeah, then this one is missing, and maybe in that VM you have here 8080 instead of 80, probably.
Yeah.
Yeah, this is one thing that I changed just before the session in order to align both the HCBeam and the VirtualBox setups, so everybody is aligned. Everybody is set up?
Just a moment.
Okay. Whenever you have the virtual machine, feel free to start the virtual machine.
I'm checking. Sorry, I'm trying to catch up with the...
Sorry?
Sorry.
Maybe you have some other service that is running on port 80? If that's the case, you can change in your particular case, instead of 80, you can put here 8080 or another port. It should not be that a big problem, because we will use this only to open the TerraFlow web UI. So I hope it should not be a problem. so. Everybody's ready?
So you have fixed IP addresses there.
These
Okay.
ones, you mean?
Yeah.
This, well, depends on your setup. Probably when you start the virtual machine, if you take the user and password, you have them in the slides. It's over here. It's TFS 123. You will get a prompt with the IP address that your virtual machine got through the DHCP. Usually it's the same IP that I had here in VirtualBox, but sometimes it's 10, 11, 12, 30, 40, 50, depending. If it's the first virtual machine, usually you get the .10 IP address. Whenever you are done, what you can also start doing is configuring your client in order that, maybe in this case I'm using MovaX term. Let me close this tab, start from scratch. So here you can configure the MovaX term just connecting to 127.0.0.1 because we are exposing it in the local host, port 22, and user TFS. Okay. For the rest, in principle, you don't need to change anything. And then, whenever you are done, if you double click, you should be able to connect. You type password TFS 123, and you should get connected to the virtual machine. Let's see if everybody reaches this point.
Just a moment.
Everybody was able to connect to the SSH of the virtual machine? Well, I go ahead in order to don't block a lot of time, and if there is trouble with any of the participants, we will address it individually. Then I will, as I was mentioning, given the issue we had, I will jump directly to the section on deploying TerraFlow SDN. So for that, the first things first. Well, I will skip this first part because it's just about software versions, requirements. You probably address this while downloading the virtual machine and importing it. The other point is that if you want to install a virtual machine or some deployment or some server for running TerraFlow, in the documentation page, you have all the details on how to proceed, okay? Here, I'm providing you the links for configuring an Oracle VirtualBox virtual machine and how to install the micro-K8s environment, that is the Kubernetes-based environment that we are using to run TerraFlow. I will not go into the details here because it might take a lot of time. If you have any question, at some point we can discuss during the coffee breaks. Then, things you will have to do. You will have to run this command. This is to check the status of the micro-K8s. Okay? In principle, if micro-K8s is running on your virtual machine, you will get a notification with all the add-ons that are configured in micro-K8s. If you don't get this, probably you need to start micro-K8s, okay? And in that case, I will show you. So here, micro-K8s, status, wait, ready. Okay, you see here we got the micro-K8s is running and everything was running here, all the add-ons. If you don't get this, as I said, you have to run this command, micro-K8s .start. Okay. After that, next step. what we will do is to check that microcades is, this is when you start, if microcades was not running, it usually takes few seconds to activate. So before proceeding, it's always good to start for getting the confirmation that it is running. After that, you can run the kube control get all to check that all the entities are properly running. So here you can do the watch kube control get all, get pods, all namespaces, oops, and one. And then what you should see here is, well, you will probably not have this part of TerraFlow, but you will have the rest. You should see that all the dependencies, in particular we are interested in checking that the container registry is running, all the Kube system entities are running, and the ingress is running, okay? Because if these are not running, probably we will have trouble deploying TerraFlow. If everything is running, then we are free to go. And here, let me do something. I will open the commands from the link that I was mentioning. Okay, it's here. Okay, it will be faster to copy commands. And second, let me find the point. Okay, so the next point, the next command that, that we need to execute is this script for redeploy TFS. Okay, let me briefly explain what this command does. It's a bit a mess having to jump slides back and forth. Okay, in order to deploy TerraFlow, you have all the instructions again in the documentation, but here briefly, the deploy scripts are organized in 4 main parts. Okay, the first 3 parts are, well, they are not in order here. The first 3 parts are dependencies. One of them is the cockroach DB. This is a database engine that we use for persisting the relational data of the TerraFlow SDN controller. The second one is NATS, which we are migrating in the following releases to Kafka. This is a message broker that is used for exchanging messages between components. And the QuestDB, which is a time series database that again we are migrating to a Prometheus plus Mimir solution. But this will happen in the next release, the final deployment. So for now, let's keep it simple, and we assume we are using this CockroachDB, NATS, and QuestDB. And then the fourth element is TerraFlow itself, okay, all the microservices that compose TerraFlow. We will not be changing settings for all this. We are keeping the deployment simple, and we provide you with all the initial configurations. Just for you to know more or less how is the structure of the settings is something like this, okay? This is the part related to TerraFlow. In particular, we specify where we want to record or store the TerraFlow microservice images that are built during the deployment. We also specify which components do we want to deploy here. In this case, these are the ones that we will use in this Hackfest. It's the context is the one that manages the data elements, the device is the one that implements the SVI connectors to manage devices, path computation does what the name states, service is the one that manages the connectivity services, NBI is the one that provides an NBI for end users to, well, end users or external systems to connect to TerraFlow and drop requests, and the web UI is the one that enables end users to connect to TerraFlow and manage things through a graphical interface. Okay, the rest is just configuration settings. I will skip them for the sake of saving a bit of time. And then we go directly to the part of deploying TerraFlow SDN controller. Usually for that, we go to the folder where you clone the TerraFlow code base. We source first the deployment specifications file. This is file with all the settings that I was mentioning. And then we run a script that is named as all.sh inside the folder deploy. Instead of doing this, given that we automated things for you and to facilitate things, we will use a command that not only deploys TerraFlow, but also does some cleanup in the virtual machine in order to save a bit of resources. Okay, so you can use directly this command, TFS Hackfest 5 redeploy TFS. That's what we will do right now. So let me copy the command. Copy the command here, we paste, and then when we run, you will see that it will start cleaning up some things, and then it will start redeploying all the elements. This is the step that I mentioned to you that might take easily around 20 minutes, given this change that we had in the dependencies. So while it is deploying, I will jump to the theoretical part, the theory part of the Hackfest, so that way we progress, and then later we will come back here and check. Okay, that's good. Something crashed. Perfect. Good way to start. This is not expected. Okay, now it seems to work. Okay, for some reason, the first time it crashed. I recommend you going first to the TFS CTRL folder and then running the command. For some reason, it was not working smoothly the first time. I jump back to the slides now while it is deploying, and we find the point, yeah, and go here. Sure, yeah. Everybody was able to start the deployment of TerraFlow? Right, who was not able to start the deployment of TerraFlow? Okay, 1, 2, 3.
I had a problem with the port number 50080.
50080.
The CLAB G.
Yeah, probably it's because the service is still not started. We will start inside the virtual machine this service later.
This is in the virtual box. Port for working.
In the virtual box. It's saying that it is
invalid.
Use. Invalid.
Is it 50080 the correct one?
Yes. 50080.
Yeah. Okay. I'll try that again.
The rest? Did you succeed to start deploying TerraFlow? Is somebody blocked some issue? Yeah.
Shall we use?
Yeah, you should use this one that I was mentioning here, the redeploy TFS inside the Hackfest 5 folder. But I recommend you running it. I'm not sure why, but better to run it from TFS CTRL folder, even if you provide the entire path. For some reason, there was some internal in the script that raised the issue in the time when I ran this. In my case, you see it is now deploying and building things. The rest, is it running for everybody? So,
from the folder that you just told me, the script starts running. Before I was inside the Hackfest 5, they couldn't run it.
Yeah, it's...
But now the process has started.
Okay, so essentially you have to do this. So go to the TFS CTRL folder and then run this script. Everybody is at this stage? Okay, I understand for everybody TerraFlow now is being deployed. As said, it might take some minutes, so I continue with the presentation here. Okay, what was originally the first part of the presentation was on protocols and well, for controlling and managing the network devices and so on. I don't want to be so extensive in the explanation because the idea is that I provide a high-level view in order to give you a bit of background in order to follow the Hackfest. So you will see that I'm touching all the topics just at a very high level. Okay. For the first topic that I think it's convenient to address, it's young language. I don't know if you are familiar. Is somebody not familiar with young language? Okay, I see a couple of some hands rising. The idea of young language is that it's a language that enables you to describe a data model. What does it mean? When you want to encode some information, you can use different encoding schemes or ways to organize the information and so on. The problem is that you need to define fixed ways in order to create interfaces that can be reused by different systems, and then the systems understand each other. So that's the kind of things that we can do with young language. Okay. Here I provide an example just to illustrate what I mean. Imagine that I need to define a schema for representing a basic topology that contains a list of nodes, a list of links, and then each node has some couple of fields and a list of ports. Okay, what I can do is define, okay, at the top level, which is at the bottom here, I have a container that is named as topology, and inside topology I use a group named as topology that contains a list of nodes and a list of links, what I was mentioning. Each of these lists has a key that identifies uniquely the internal elements of this list, and each element is encoded as, well, is represented as a group node, group link. Okay? The node contains a leaf that is node identifier, which is of type string, and also contains a list of ports, and each port is identified by a port ID and uses the group port. This group port has a single leaf that is the port identifier, which is of type string. Okay, so at the end here, I will show you later a tree. Here, let's go for the first part. You see that I have topology on top. Inside topology, I have a list of nodes, and each node has a node identifier, which is a string, a list of ports that are indexed by the port ID, and then they have port ID. Oh, this thing, it's wrong. I need to remove this. This should not be here. And then, to see, for instance, an example encoded in XML, how could it be represented? I will have topology. Inside topology, I have node, well, a list of nodes, and then for one node, I have the node identifier, the port, well, the list of ports, and for each port, the port identifier. For the other, I have another list of another node with another port. In the case of the links, each link has a link identifier, and then if they have, for instance, a source node, a target node, source port, and target port. And these four values are not free strings. It needs to be strings that are in the previous node list. Okay, so I cannot put whatever thing I want. It needs to be something that references an existing entity in the nodes. Then, if we check here how a link could be, a link can have a link ID. This is a free string. Okay, and then the source node is router 1, that essentially is a pointer to this node. It has a target node, router 2, which points here, and then I have the pointers to the ports. That's the idea. It's more or less clear. Young. I don't want to go into the details. I mean, Young, it's huge if we have to specify it, but I think for the Hackfest is enough to understand up to here. In terms of netconf protocol, the idea of netconf protocol is that it's a protocol that enables to manage network devices. That means I can configure the network devices, for instance, defining which is the IP address of an interface, or maybe creating a network instance, or whatever I need. Maybe installing a static root for a specific network domain, etc. It's based on layers. So at the very bottom we have the transport layer, usually implemented through a SSH. On top of that I have a number of RPCs, remote procedure call methods that I can use to configure. Here you have a list of them, of the operations. Well, the operations are implemented on top of these RPCs. And the common ones are the get, the get config, edit config, copy config, etc. Okay, I will not go again in the details. If you have interest, we can discuss later. This is just a standard. And then we have at the top the content layer, where we have the actual configuration that we are managing in the device. Next point, it's on the gRPC. This is gRPC. It's a high performance and general purpose framework, which is quite rich in terms of features. It's highly performant because it's based on HTTP2. At the end, that means that we are not conveying text for the request and the replies. It's binary data that is encoded and in some cases also compressed. So it's quite efficient. And together with gRPC, we have protocol buffers. That is an interface that enables it's an interface description language for the gRPC. As a very simplistic example, imagine that we want to implement a remote procedure call that enables to, for instance, search on a remote server. Imagine that I have a server that is a search engine, and my client wants to do some search. It can use a method search that I define here, RPC search, accepts as parameter a request message and returns a result message. And the request contains a string that is the query, and the result contains an element that has a string with the title of the page that I was looking for, the URL of the page, and also a snippet of the page, for instance. Well, this is just a simple example to understand what gRPC and protocol buffer means. Again, as it happens with Jan, the definition is huge, but we will not go into all the details now. I was explaining this just for you to know that then the GNMI protocol that we will be using today is based on gRPC, and it's kind of an evolution, let's say, of netconf or resconf for managing the devices, but using this gRPC-based interface. Okay. In terms of GNMI, it implements 4 methods that enable to interrogate the capacities of devices, get the configuration of a device, set configuration on the device, and also subscribe to telemetry. In terms of the request and the response, well, probably we can skip in order to save time. But the idea is that we can provide in the request the paths to the elements that we want to retrieve, and we get notifications, for instance, for the get with the information that we were asking for. Okay. Up to here, more or less, it's clear. I know that I was flying on, over these topics, but I mean, explaining them in detail might take a full afternoon, so I don't know if it's everything clear up to here, more or less. Okay, then I go ahead. OpenConfig. OpenConfig is a data model that is used for both configuration and also for retrieving telemetry data from the network devices. Okay, it's huge. Again, it contains a lot of modules. It's written in based on Yang language, and well, we will not go through all of them. The ones that we are interested during this Hackfest are mainly the interface here, and also the network instance, okay? Because interface enables us to configure IP addresses in the devices, and network instance enables us to configure static routes in the devices. That's it. I will not bother you more with the rest of models. This is how it looks like in terms of the interfaces, for instance. You see that for an interface, you can define which is its name, which is its configuration, for instance, the type of interface, description, if it's enabled or not. In terms of telemetry, for instance, for the counters, you can have for a specific interface, which are the packets in, packets out, bytes in, bytes out, and so on and so forth. Detail for the sub-interfaces, as said, it's huge. And for configuring IP addresses, for instance, you can extend the OpenConfig interfaces with the part related to IP, and then you get an additional section for IP before addresses, where you can configure the IP address of a specific interface. Okay, this is just what I want to explain to you in terms of data models, interfaces, and protocols. Up to here, is more or less everybody following? Okay. Before jumping to ContainerLab, let's see how is the deployment of Teraflow. Okay, on my side, it finished. Did it finish for all of you? Or is it still building? Still building? It's finished on your? Okay.
Can you say again the script that should run?
Yes. When it's done, usually what you should see is, well, let me go up here.
So is it in the page of on the README? So I didn't see that.
In the command to redeploy Teraflow, you mean, or to see the status of the deployment?
I'm not sure whether it's after the ContainerLab commands.
After ContainerLab commands, yeah.
So which is the,
we have all these. This is just to activate the microcage. Well, check the status of microcage, activate microcage. It waits here until the microcage components are available, and then is where we run the Teraflow deployment command. Yeah? Yeah. Is who is still building or deploying Teraflow? Okay. At which stage you are? What do you see on your screens?
Waiting at stateful.
so
Waiting NATs.
So do we need to go download the Arista images and then start this one, or is it inside the image?
It's in the virtual machine already. Yes. So you are here. You are here. The ones that were in the waiting for the stateful. No. So, at which stage you are? Then. In the? Okay, so you are over here at the very bottom. Service. Web UI, it's processing the Web UI component on your case, right? Okay, well, it's almost the last one. Then after that, it's monitoring, and then we will be done. Okay, let me start with the explanation on ContainerLab before we go. Well, we go ahead with the part of Teraflow. Okay, ContainerLab. So ContainerLab, the idea of ContainerLab is that it is a network emulation tool that can be used to virtualize multiple network operating systems, for instance. So the idea is that imagine you are a network expert, and for whatever reason you need to deploy a small testbed to test some specific device. Maybe you need to test some specific service tape or whatever. The idea is that with this, with a network emulator like ContainerLab, there are a lot of them, but ContainerLab is quite convenient. You can deploy a small topology with the devices that you need. You provide also the wiring between the devices. You specify how you want to wire them, and then you can get access to configure these devices using, for instance, protocols like the GNMI that I was mentioning before. Okay. ContainerLab supports a quite large number of device kinds. I will not go into the details again because it's something that takes time, and you have the links here for the ContainerLab in general and also for a quick start. So I invite you to investigate a bit if you are interested and you like what you see here in the Hackfest. Examples of topologies, for instance, you can have simple things like, for instance, just a couple of routers interconnected among them. You can have even parallel connections between devices. You can create spine and leaf topologies, even with super spine, whatever you want. I mean, at the end, you can define the connectivity. The interesting thing is that you can mix, for instance, devices from different manufacturers. You can deploy, for instance, containers that or machines that run just a Ubuntu or a Linux client, so that enables you to throw commands directly inside this testbed. So at the end, it's a virtualized testbed. The scenario that we will be playing with is this one. So in this case, what we will be deploying will be a couple of Linux clients that will be interconnected through a sequence of two routers. Okay. All these devices will be connected to a management network. This management network will be used only for getting access to the different elements, but not as a data plane. Okay. We will provide static configuration in the two clients that will act as data center 1 and data center 2. So this configuration is already given in the scenario that we are giving to you. And the thing that we will leave for TerraFlow to configure is all the settings related to the routers. That means the IP addresses for the data plane interfaces and also the intermediate range. So that means if you see here, there is a block, for instance, that has no settings, no hint on what to use. The idea is that TerraFlow will be able to decide a set of parameters to configure here in order to provide the end-to-end connectivity. Okay. How is the descriptor for our scenario? This scenario will have, well, as I was mentioning, a management network that we will use to control the devices or to configure the devices. And then in the topology, we will have two kinds of devices. One of them will be Arista routers, the COS routers. The other will be Linux machines. Okay. The nodes, router 1 and router 2, as said, are Arista COS devices with this IP address used for management. And data center 1 and data center 2 are Linux clients with these IP addresses that we can use to SSH on them. And then also these two data centers, they have the ETH1 interface that is pre-configured with a MAC address and also an IP address, and they have a static route installed on them. The idea is that the data centers are not managed in this case, in this specific scenario, by TerraFlow. So we are assuming this configuration is given initially. The connectivity between all these elements, interface 2 of router 1 is connected to interface 1 of router 2, and then the two routers are connected, the interface 10 of each of the routers is connected to one of the data centers. So this results in this setup. It's a linear setup. Okay. Some commands in order to run ContainerLab. The first one is to import the COS image. This one, in general, you need to download it from the web page of Arista. This can be downloaded for free. You just need to create an account and you can download the image. With this other command, you can check. Well, this is already done in the virtual machine, so in theory you should do nothing. In terms of checking the images that are installed, I will copy the command and I will show you. Let me go to the ContainerLab section. We'll check here that in the virtual machine the images are in place. Okay, you see we have the COS and we have also this network multi-tool. It's essentially a Linux client that has some tools like pings, config, iperf, and so on installed. And then the next command will be to deploy ContainerLab. But before running that, I want to ensure that everybody succeeded in deploying TerraFlow, because if we deploy everything at the same time, it might be a bit of a mess. Is anybody having trouble deploying TerraFlow? Almost done? Okay.
So maybe Lluis, in the interest of time, maybe Cheyenne or Alan can help them. So
yeah,
you can go ahead.
If they are having trouble, maybe people that is skilled can assist. But well, if it's running, otherwise I will run a bit. Well, for those that already deployed the TerraFlow, I will go to deploy ContainerLab. So for that, you have a command, the TFS controller Hackfest 5 CLab deploy. This command, you can run it directly in the virtual machine. Then if you run, password TFS123, and then it will start deploying the environment. It might take some seconds. Now it's building all the elements of the testbed. It's creating the links between the elements, and then it's running some post-deploy actions that in practice means some pre-configurations and so on. While it's running, I will, well, whenever it finishes, what you should see is something like this. It's a summary of the different elements in the testbed that were deployed with the specific image that was used, the IP addresses, the kind of element they were, and so on. Okay.
You know, when I do the git pull, there is no deploy in there.
In where?
There is no CLab does deploy after the git pull from this one.
After the git pull.
Yeah, I mean the CLab deploy.
Just in the interest of time, I have requested before some
Yes.
people to help the people remaining, because if
Cheyenne
not, we are not
take a
advancing
look.
enough.
Yes.
Thank you.
It's delaying quite a lot. Okay. Then, now CLab is deploying. Let me go to the slides. Then the next stage, whenever it will finish, what we will run. Well, we can inspect the scenario with the CLab inspect command. We will skip because the deployment ends precisely with this. So as soon as it finishes, you will see the deployment. Let's see. It completes. Today it is running slower than it was expected during the preparation. Okay. The next command that I will show you is this GitLab graph. Whenever it's done. Okay, here we are. You see that here, after the deployment finish, you have all the elements running. Now you can, oops, not this. Okay. When the deployment finished, you can run this CLab graph, and then if you go to the one, yep.
This part, the ones who are using the extreme have to put instead of the local host, the
Yes, exactly. You have to put the, if it's at CVIM, you have to put the, and then here, well, you get, this is just to showcase you that you can get the topology of ContainerLab. So I will skip this part, I will stop this graph. So now at this time we have TerraFlow and ContainerLab deployed. So, where is the slide? Here. So, additional commands of interest, we will use them later. So maybe now I will not spend time on them, but we provided some commands in order to connect to the command line interface of the different elements. Also, not only the routers, also the data centers. Later we will use them, so for now I will skip in order to save time. And also, don't run it now, because you will destroy the testbed, but there is command in order to destroy, as I mentioned, the overall testbed. Deployment of TerraFlow, this is done, so I fly over this, and then we jump to the interesting part that is on onboarding the scenarios. I don't know how we are in terms of time. What is the coffee break? Now. Okay. Maybe we can stop now and then we continue after the coffee break. So if there is somebody blocked, we can fix it now in a moment, and then after the coffee break we continue, and I will try to speed up things. Okay, thanks. So let's continue now with the Hackfest. The next part will be on how to onboard a scenario in TerraFlow. Now we start hopefully with the funny parts, and let's hope that we will not have additional trouble. So how to onboard the topologies and the scenarios in TerraFlow. The idea is that in the web user interface, as you will see in a few minutes, we can upload some JSON files that are follow a structure that I will explain in a minute, and they provide or they enable you to define things like, for instance, the context and topologies that you want to deploy in TerraFlow, the devices, the links, create services, create slices, and so on. All this is using a custom but open interface from TerraFlow. Okay. In this description, I will focus on the context, topology, devices, and links, because for the services and slices, we will use the IETF layer 3 VPN model. So let me explain the structure of the files. Let me activate the pointer. The structure of the files is well, like this. In this case, it's for the context and topologies. The idea is that a context gives you, as the name states, a context for a scenario, and topologies are specific views of the topology within a context. Okay, there is a special one that is the context admin topology admin that has a view of everything that you onboard in TerraFlow, but then you can create other topologies in the context that have specific views only of particular segments of the network. I will not go into these particular views because it might take a while. So let's just stick on this admin. You see the descriptor is quite simple. I was highlighting in red the specific placeholders that you need to fill in. So admin. Then for the devices, this is an example of how a device is described. You see that it has an identifier, the type of device. Okay. It has also the drivers that can be used for managing this device, and then you have a set of configuration rules that you can use to onboard the device. There are three special configuration rules that are these connect/address, connect/port, connect/settings that are used to configure the driver itself. So this points to the specific This specifies the IP address of the management IP of the device and also the management port. And for settings, you can provide whatever is needed. This specific case that I'm showcasing here is for emulated devices, okay? So in this case, we specify the driver undefined, and undefined is used for emulated mainly. For the device tape, in this case, this is for a data center. So you see that we are using here emulated data center as tape. And given that it's emulated, there is nothing outside TerraFlow that is managed by TerraFlow. In reality, we have the client, or the data center in this case, but given that TerraFlow is not managing it, and TerraFlow needs to know about it, we just provide a placeholder for this data center, and that's what we name an emulated element. Okay, that's and we provide here as IP addresses that it's default values that are ignored. What we need to provide for an emulated device is the endpoints, because given that we are not connecting to any external entity, we need to define the settings that are required in order to manage this device, and the list of endpoints is the very minimum information. In terms of a router, for instance, a GNMI OpenConfig capable router, we define as device tape packet router. We provide here as the device driver the GNMI OpenConfig. We provide the management IP address and port of this router, and then as settings for this driver, we provide the credentials in order to connect to the device. For the links, very simple. We just provide an identifier for the link. This is a free string. The only constraint is that they should be unique. And then you specify connect router 1 interface Ethernet 2 with router 2 interface Ethernet, well, port Ethernet 1. That's it. Particularity for bidirectional links, you need to create the two directions, okay? Here, the links that are created, and this is because in optical networks specifically, sometimes it's important to define unidirectional links. What we assume is that all the links are unidirectional, so you need to provide the two for bidirectional. Then let's start playing with TerraFlow. You have the descriptor available. So now what I will do is jump to the browser. Let me connect to the TerraFlow. I'm connecting through the 127.0.0.1, but if you are using the Etsy Beam, remember that you need to provide the IP address that Roger provided to you. Okay? So we connect to TerraFlow. Right now we have nothing in TerraFlow. So what I will do first is let me download the descriptor for this Hackfest. This is in data, TFS topology, download. Okay. Then I will pick the file, submit, and if everything works fine, in a couple of seconds we should see that the different elements, you see, were onboarded. So we got one context, one topology, 4 devices, 6 links, and also one topology updated because the different elements were added to the admin topology. If now we select the context admin topology admin that was created and we press submit, we can see the topology the representation of the topology with data center 1, the router 1, router 2, and the data center 2. You can also browse the device tab and you can see the details of the different elements. For you to know, this icon that you see here, if you press it, for instance, I will go for one of the routers, you can go to the details, okay? And you can see, for instance, for router 1, the unique identifier. You can see also the endpoints that were discovered directly from the device, the driver configuration settings, and also, well, the endpoints, interfaces, and so on and so forth, all the configurations, okay? You can also see the links here that define the topology, and at the very beginning we have no services, okay? So up to now, at this stage, we have TerraFlow with a topology onboarded. Here, let me jump again to the slides. So well, this is what we did to inspect the elements. In case you have trouble, you can always run some scripts that we have that are the show logs and then the name of the component in order to check if there was some error or which was the error or something. In general, the errors are managed and the web UI reports them, but in some spot cases might happen that maybe they are unhandled errors. You can check over there what's going on.